So previous lesson is free for anyone can explain about the free flow. Okay, hi, good morning, good morning everyone. Okay, thanks for your response. So can anyone volunteer to just briefly write about how is the free flow? Just simply request. Don't be too worried. Free flow. Anyone's? You can refer back from the textbook. It's okay. Is that typing? Okay. Hi. Okay. Yeah. This motion affected. Yeah. Only affected. Yeah. Okay. That's good. Also, from previous lesson, free fall is the motion of an object only affected by the gravitational force instead of the external. So we're going into the topic today. So do anyone know how is the topic today? We're going to enter to the next topic. Anyone knows? If don't know, just write don't know. It's okay. Share. Anymore? Anymore? Share. With the next. Okay. How about others? Momentum. Okay. How about others? So for the topic today, it should be inertia. So momentum will be afterward. So we're going to learn about the inertia today. So before I going to let you all watch a video, can anyone give me the example or can give me what is inertia in your knowledge? Do you know? Just give me what is in your concept. What is the inertia? If anyone's volunteer, if don't have, it's okay. So we're going to watch video later, so you have a very clear concept about the inertia. When I know about the inertia already, you can write in the chat box or you can open the mic also can. So since like don't have anyone know, so we're going to watch it for me as something with movie or an interest. Okay, thank you, Alice. So Alice said it from in her in his concept that the initial is doing something with the moving and areas. So before we talk about the concept, let us watch a video so that you have a clear image about this. If you don't have cannot hear about the voice, you can write in the chat box. I will look at it. So for the monitor, mention once again. Remember to take the attendance. So if my voice is does not clear, you can tell me also. Okay, so watch the video.
Mr. Jim, the audio is not clear.
Excuse me, sir.
Mr. Jim.
Teacher.
Mr. Jim. Hmm.
Teacher.
Mr. Jim. Aye.
Um, your teacher is the middle supposed to be. Oh, yeah. Yeah. Um, oh, I hear the voice. Okay. Over. I'm using a earring. The earphone. Uh, wait. I'm trying to fix this. How about now? Can you hear the voice?
No.
How about now? Actually, present. You see? Yeah, I'm. Yes. So it cannot. So all of you cannot hear the voice, right?
We cannot.
Okay. You can stop sharing and share again using the Google Meet. Okay. Stop sharing. Share again. Google Meet Ocean. Deal. Share using earphone. Press present now. Um,
Solution. Oh yeah! Did you observe that the bag fell when brakes were applied? Do you know why this happened? This happened because of inertia. Inertia is the tendency of a body to be in a state of rest or in a state of motion. Newton's first law of motion defines inertia. It states that a body in rest stays in rest, and a body in motion stays in motion, unless it is acted upon by an external force. So, in this case, when the bag was on the bike, it was moving along with the bike. Now, when brakes were applied suddenly, the bike stopped, but the bag kept on moving forward due to inertia of motion, and hence it fell. This time, the bag fell again. Can you guess why? Yes, you guessed it right. It is also because of inertia. When the bag was on the stationary bike, it was at rest. Now, when the bike was accelerated suddenly, it moved forward. But the bag being at rest did not move due to inertia of rest, and hence it fell down again. In this case, when the bus suddenly starts moving forward, our feet, which are in contact with the bus, start moving forward. As a result, the lower part of our body moves forward, but the upper part of our body, which is not in contact with the bus, still tends to remain in a state of rest. That is, the upper part of the body does not move forward along the lower part. That is why we tend to fall backwards.
Okay, so that's all for this video. Is that interesting to watch? Have you learned something from it? So can you tell me about how is the inertia? Or you may give me a side example also can. In the chat box. So how is the inertia? So yeah. So is there anyone want to give me example? If not, I can move on to the textbook. So I move on to the textbook. So from the video, we can know about clearly, and we can know clearly about the inertia, which is there's two important points. Anyone can give me which are these two important points about the inertia. Just now I show two examples. So let us memorize that. From the first situation is yeah. So for the first situation is the truck draw a thorns and put in the ground, open the rest and yes, and it stopped the bike immediately, but the bike flies further than the motorcycle. So this is in the state of motion. So for the next situation is you put the bag on the motorcycle and it accelerate immediately. Just happen and rest. Yeah, accelerate immediately, and then the bag is stay at rest, but it already accelerate far away. So there is two important things about the inertia, which is the inertia has the tendency to stay in the rest or stay in the motion of stay in the motion. So we look into the textbook. So the inertia is the tendency. So is the tendency of an object important to remain at rest or moving to continue its motion in straight line at uniform velocity, or you can say that the inertia is the tendency of an object to remain at rest or stay in the motion with at uniform velocity. So from this picture, we can know about the inertia also. That chrome, they quickly pull off the tablecloth, tablecloth. So the things on the table does not move, but it's pulled off the cloth already. So this is the Newton first law of motion, state that an object will remain at rest or move at uniform velocity unless acted upon by an external force. So we look at this concept of inertia. So actually, you done the experiment at your home. That you just take a glass. You don't need to fill with water. Also can. It's fill with water is better. And then a thick cardboard and put a coin. And then you quickly jet the cardboard. Use the finger. Use your finger jet the cardboard. So the coin will remain at rest and fall into the glass instead of it move together with the cardboard. So we recognize the inertia. Okay. So from here, I'm going to show you because we cannot do the experiment together. So I'm going to show about the experiment using the YouTube video. So you have clear about the experiment that we can done in daily life. Share again using the tab. As a growth count as an example. The ball which arrests remain golf. Um, Alex, can you give me more detail? Is you mean the golf spot or golf club hit it? Actually, if you think is in the motion in the time when the golf club hit it, it's not counted as inertia. But if you put it, you did not move it, it's counted as inertia because it's there in the motion at rest. Unless yes, so it's counted also. So I'm going to present another video, that about the experiments. There's 5 experiments. I hope that it can impress you a lot. Share, present, tab, motion. Okay, this is a 5 inertial activity that we can know about the concept of inertia.
So Newton's first law of motion was that an object at rest wants to, everyone say, stay at rest. Stay at rest. An object in motion wants to stay in motion. Stay in motion. And essentially, that is Newton's first law, and that is the concept of inertia. Let me show you with what I call an inertia hat. Now this might look pretty funny, right? This doesn't really look like a hat. I made it out of a coat hanger and 2 tennis balls. And if I place the inertia hat on my head, does it have the inertia of being in motion or staying at rest? Staying at rest. Staying at rest. You might see just a little bit of movement because I'm talking, and there's slight movements with my head moving and with the air in the classroom moving, but for the most part this is staying still. Now watch what happens if I change the inertia by applying a force. So here's the force. Now what inertia does it have? Staying in motion or staying at rest? Staying in motion. And it's going around and around until the friction from the hanger hitting the top of my head slows it down. Now it's slowing down and it stops. Now I'm going to move. And did it change? Did it start moving? No, because there wasn't a force applied to it like when I moved it with my hand. There is friction happening, and because I'm not keeping my head perfectly still, there maybe was a little bit of a wobble, but it didn't really move. It mostly stayed still because I'm going to show you how to make your own inertia hat, which is great fun for
You show
spin around and have the hat stay
inertia
still,
hat.
or
It
giving
will show
just
how
a
you
little
do it.
push
If you're interested, you
and
can
letting it orbit your head like a pair of planets. There we go.
You see?
Smoother push. It goes
When you
round and
push
around
the
like
ball,
it's orbiting.
it
orbiting
doesn't
the sun.
flow. It just
Lots of
stay
fun.
in motion. Okay.
So So to make one, you just need a coat hanger and a little bit of patience because it is tricky to get it to balance like this. So the first thing you want to do is untwist your hanger so that you just have the wire. And you're going to try and get this as straight as you can.
Okay, straight. And then bend into the half.
The straighter you get your hanger, the easier the next part is. So it doesn't need to be perfectly straight. I'm calling that good enough. Now we're going to bend it approximately in half. And once you get it bent in half, then you are going to take the ends and curve them down in an M shape. And you want the bottom part to be lower than your middle or your V. So we get them kind of heart-shaped, rounded. There we go with that end. And now the other end. And you can use pretty much anything to go on the end. So these tennis balls, wool dryer balls work well. I've got this one that I made with squeaky toys from the dollar store and little styrofoam eggs. These are a little bit too light. They don't work quite as well as the tennis balls, but they're a little more comfortable on the top of your head when they're lighter, so plus or minus depending on what you use. You can see how this hat is not staying up straight, it's tipping forward, and that means that it's not in line. So I could try to adjust it by pulling something back a little bit and then just balance it on your hand and see if that looks better. And it won't take too long for you to figure out that minor tweaks make a big difference. Even it out. Whoa, and see, all of a sudden I did something wonky, and instead of the hat balancing upright now, it's balancing in that weird crazy angle, and we don't want that because it's not going to stay on my head well if it's not balancing upright. So I need to try and tweak it back, see if that was enough. There we go, now we're almost upright again. Maybe. Yes! I want to tell you something important about inertia.
Let's
Mass matters when it comes to inertia. The amount of stuff that you have, the amount of weight, is going to make a really big difference. I'm going to be applying about the same amount of force each time I flick my finger. And is it a whole lot of force or not that much?
Before you pull, actually here putting 3 bottles. One is fully filled, one is partially filled, and one is empty. Later, let us see that what's happening when you pull off the cloth table.
Right? Now, here is an empty water bottle. It's really light. Here is a half full water bottle, and here is a water bottle that's almost all the way full and is a lot heavier. Watch what happens to these water bottles when I flick them. So, the light one just fell right over, right? That one tipped forward, but then went immediately right back. And that one I just hurt my finger, but it really doesn't move very much at all. And that's because this one has more weight. Everyone say inertia. Inertia. It has more inertia. So, which one moved the most? This one did, right? And it's because it is light and it doesn't have as much inertia. And so when I pulled it out, this one tipped over. Did you see any difference between how these ones behaved?
No.
This was interesting. We had, just like Goldilocks and the Three Bears, we have too light, too heavy, and just right. Now, right now, these Easter eggs, which are full of Play-Doh, so that makes them kind of heavy, and things that are heavy have more inertia. These Easter eggs, are they at rest or are they moving?
Rest.
They're at rest, so they have the inertia of wanting to stay at rest. And if I apply a force to them, they'll move. But if I don't apply a force to the egg, but instead apply a force to the pan, then I should be able to get the egg to land in the cup. You guys ready? 1, 2, 3.
Oh my god.
Yeah, we'll do 1, 2, 3, go. Woo! Round of applause for the boys. They're amazing. There's another variation on this we're going to do now with bunnies. So, and this time, I would like to have 2 students come up. And 1, 2, 3.
Wow.
be like
Same concept about the
slow motion pulling back. Let's see
putting
what happens. Okay?
very quickly
1,
that the
2,
body
3.
will stay at rest.
Slowly go back.
But from this, it pulls slow.
Very different, right?
Okay, this is another, the last about the inertia beat. It's amazing.
If I give this string a tug and get them started, once part of this string of beads has inertia,
It will stay.
it starts moving and it wants to stay in motion. It wants to keep moving and it pulls the rest of the beads out. But if you watch closely, you'll see something really cool. When they come out, they don't just come over the top like this, they actually lift up and over the edge. You guys ready? Happens pretty fast. I'll put them in and we'll do it one more time.
I thought
You
you
can
would
buy inertia beads online, but you don't need to. You can make your own by taking party necklaces,
the beans will hit,
cutting them
moving up
apart,
and then pull,
and
go
then
down, stay in the
fixing them
state of
together with
motion.
duct tape.
So it
This is the
just depends on
47th
that.
string in my homemade inertia beads, and when you put them in the container, you just need to be sure to put them in bit by bit, the same way that you want them to come out. So let's give them a tug and see how they do.
So taking the motion in slow motion, you can see clearly about the motion of it. Amazing.
Not bad. When you put them back in the container, it's important to feed them in the same way that they've come out.
So actually, that's all for the experiment that show I'm using the video. So actually, okay, let me stop sharing. So actually, from this experiment, have you found that one of it is about the water? What can you make about the hypothesis about the experiment that using the water? And maybe let you have 3 minutes think about it. Just now here using a water to do the inertia experiment. Do you still remember it? The bottle, 3 bottle, one is lighter, one is middle, and one is very heavier. So from the experiment, I want all of you make a hypothesis about the relationship between the inertia. You can think about it first, or you may discuss with your friend also. After that, you write in the chat box. Is that my voice? Can you hear me? Higher, if it has higher mass. Okay, okay. How about others? I want most of you can write in the chat box. Higher inertia, higher mass. Higher mass, lower inertia. Why? Can you explain why? Joy and the cream. Okay, why you say that higher mass, lower inertia, and for Joy, I will say that higher inertia, higher mass, higher mass, higher inertia. How about others? Then give me your hypothesis. It's okay. Either wrong or correct. We will learn from it. You can think it's okay. We're not hurry to for it. So your flashback think about the experiment. Just now the teacher they take 3 bottles. one is lighter, empty with water, one is middle fill, one is heavily filled. So when you pull the tablecloth from tablecloth, so the lighter fall immediately. But from the second and third one, it just move a little slide. So from here, we can getting a conclusion or from the hypothesis actually that the mass matter from the inertia actually. So from this experiment, I just want to let all of you know that the mass is matter about the inertia. So the inertia will be affected by the mass also. So we're going to recognize the relationship between the inertia and the mass. So from we look to the textbook from here, that's giving two ball, which is football and bowling ball. So is it easy to move a bowling ball or a football? Which ball is difficult to stop when in motion? So I give you around 5 minutes to think about from the first question, which is that easily to move a bowling ball or a football? 5 minutes, you can discuss with your friend, and after that you give me the answer. Is that bowling ball more easily to move or the football? Why? And give me the reason. So you can think about it. Which one is easier? You can discuss with your friend also. The lower mass, the lower inertia. Football, lower mass, football. What is it? Do we have a low mass, low inertia? Okay, so since most of you can correct that the football have lower mass, so it's lower inertia. It's easier to move. So we must know that what is inertia. Inertia is the tendency of an object to remain at rest or keep moving at uniform velocity. Yeah, unlike bowling ball. So we think it in another way. Football is going to kick, right? So how about we kick a bowling ball? So we kick the bowling ball, we will get in our leg hit pen. So football is easily you just kick in and fly or moving, maybe it will fly to the break the mirror. So we're looking down. And how about which ball is difficult to stop? If we kick these two football in motion, which ball is difficult to stop? J is very easy. Which ball is difficult to stop? So from just now, this is lower inertia, this is higher. It's bowling ball, yes, because if we look at the spot of the bowling ball, they throw the bowling ball. If we want to stop in the middle, it's very difficult because it's heavier. So it will keep it the step in the motion. So we're looking at the explanation that an object with a bigger mass is more difficult actually to set in motion or stop from moving as compared to the lighter object. So what is the relation? Simple version, the inertial balance. So this is the inertial balance. Actually, is okay. Just now I will show you another example, another experiment that related about the inertia. and the mass and the inertia. So what is the effect of the inertia in our daily life? This inertia bands, okay. So so actually later on we're going to do a physics. So before that, what is the effect? Actually, this is actually extra knowledge. It's talk about the astronaut in a spaceship such as the International Space Station (ISS) are in a condition of zero gravity. So under the condition of zero gravity, only the initial balance can use to measure the mass. So shown in the figure 2.6. This is the special device that using the inertia concept. So inertia can have good or bad effect to our daily life. So what is the situation that involved in the inertia? Can you give me some example? Let you think about 10 minutes. Later on we discuss about 5 minutes, and then we're going to do a simple process. So you can discuss with your friend. That's the example. Later on I will show some example in the textbook. Actually, in just now, the video has shown some example. A, a robot will bring the money for the banks and in the past. Instead of that, is there any example in your daily life? You can think about it. Any simple, very simple example also can. So I give you around 3 minutes. And it's enough for you. 3 minutes. You can think about that. What is the inertia that happening in your daily life? Actually, inertia happen anywhere. Happen anywhere. Happen. So can you think about it? In your daily life, you can think what is the example. Anyone of you? Playing badminton. Playing badminton. Can you give more detail when the initial occur during when initial occur uh, when you're playing the badminton? A leaf suddenly move down the human body. Slowly move. Okay, it's yes, less. This example accepted. when you crush the car. Okay, yeah, when you crush the car, so when you crush the car, what is the motion of you and what is the motion of car? Can you explain about it? Further explain? Excuse me. Joy, actually it's correct for badminton, but you have to say about what is when the inertia occur during playing the badminton. So maybe what is the motion of the ball? Your motion of your body will move forward. Yes, but how about the car? So the motion of the ball of badminton. So actually, if you're talking about the motion of the ball of badminton, it's not quite correct because it's extended by the external force by through the racket. So actually for playing badminton, if you're badminton player, when you're hitting the ball from the another side, and you want to hit the ball from the another side, but you can feel that you are very difficult to change your motion of body from the left to right immediately. So that also is a state of inertia also. Yeah, but only at that moment the car will stop and will run. Yes. Yes. So any more other example instead of the car crashing, the accidents? So from the accidents, you can see that many people that didn't um, take the seatbelt. So when they crash in an object, for example, crash in tree and others slowly, they will fly out from the mirror, lead out, okay, forward. So how about others? How about others example? Very simple. When your mother is driving the car very fast and it turn to the left and or turn to the right, you will also feel that your body will move to the, if it turn to the left, you'll move to the right actually. It's also is example of inertia for the tomato sauce. Yes, pour the tomato sauce. When the escalator suddenly stopped, body will move forward and forward. Okay, the escalator is okay. It's only can explain the state of arrest. Move right also can a little bit. So for the tomato sauce, okay. So what do you do? Pour the tomato sauce. What is your action? What have we done when we want to pour a tomato sauce? We punch the bottom of the tomato sauce, right? Why we do that? We do that because of inertia. Also, so we pull down in textbook several. Have you rotate your umbrella? I think maybe some of you. I also have to such thing when I'm in the secondary school. So when rain, we will play the umbrella to rotate the umbrella. So the raindrop at the top of the umbrella will fall down like flower. So the raindrop on the umbrella in motion as the umbrella rotates. So when the umbrella stops, the rain at the inertia of the raindrop will cause the raindrop to continue in motion. So you rotate, and suddenly stop. The raindrop will continue move and lift the surface. Actually, it's when we're using the run. After that, I will rotate it also. So make it the raindrop above the surface become less through this motion. So next is bus. Actually, it's not only bus. Maybe it in the LRT also. If you LRT when you enter and suddenly you move will move backward because it stay in the rest of motion, and instead because it remain in the state of rest. And then after the bus move in the uniform velocity, and then it stop immediately when it saw a child want passing through the road. It stop immediately. Our body will keep in the state of motion, so we were moving forward when the bus stops suddenly, because the bus is stopped, but our body is still keep in the motion. So in the inertia of the passenger, keeps them in their initial state of rest or motion. This is the tomato sauce. So to pour out when the gas is moved very quickly downward and then suddenly stop, the inertia of the soap will causes it to continue moving downwards and out of the bottle. So when we want to pull the chili sauce or tomato sauce, we just simply check the tomato sauce. Actually, it also can, but it's very hard. But when we quickly punch at the bottom, the glass will move very quickly downward. And then after that, the glass will stop immediately. Then the inertia of the sauce will cause it to continue moving, and then it will easily pour out the tomato sauce of the chili sauce. So this is a extra knowledge situation for that. The oil tanker track have a large inertia. In fact, that an tanker track has its door tank divided into several separate tanks. So the several separate tank will reduce the impact of the inertia of the petrol. Why? Actually, it's separate tank, then the mass will be separate also. So we know from the example that the mass better the inertia. So in the separate tank, it will reduce the inertia actually, because the mass in each of the tank is separated. If we put all together, the mass is sub total out. So it will causing a very large inertia in this situation if we don't separate it. So all this, for those who have gone for the somewhere Lego, so I'm sure that is has explained this before. The roller coaster change the direction. So this is the example of the seatbelt car crossing. So okay, is there any problem with this chapter, inertia? Have you clear about it? So what is the inertia? What is the definition of inertia? This is important. Anyone can write it. What is the definition of inertia? Simply revise about the inertia. Later on, we're going to do quizzes. Only 7 questions. It's very easy. So it's okay. I think we're running out of the time. So for all of you, please join the quizzes. Copy the link address. Okay, no, this one. Sorry. And I put it here. Okay. I hope all of you join. Just have a very just have entertainment from that to know that whether you know it or not. Just only 7 question. Um, try to you join before 23, so 1 minute from a question. Sorry, 6222181. For the code is 6222181. Yeah, I write here. 6222181. we have actually excluded me and Guangzhou. We have around 80, 82, I think, 82. So please hurry, few more. Oh, we end at 12. It's okay. Maybe I give time until 25. This is good too. Is there any problem? Is there any student facing the problem of joining the quizzes? You can tell me. 76. Few more. How many of us are 88? 2 of me. So it should be 85, right? 85. This one. Oh, yeah, 7 join. Please join. Is that all? Can I start now? Anyone haven't joined yet? $76 if I wait until to 25 and some more 25 26 25. Any more student? Please hurry up. 80. 5 more. If I'm not mistaken, should be 5 more student haven't joined. Any more? If don't have, I will start immediately. Counting down. So 3, 2, 1. Okay, start. So 66 out of 68 out of 82 is done. Question. Done. Okay. Still have 12 more. We will simply look through the question together later. 10, 10 to go. So congratulations for those who getting all correct. Six more. Five more. Is that difficult? I think it should be okay, right? Just a simple concept question. On those done, do you have any question about the inertia? You can write in the chat box also. You can try to answer while waiting for others to complete. It's okay. I think that's fine. Okay, it's okay. For that too, even done. Are you sleep? Okay, it's okay. So we look through the question now. The first one, 7, 78 correct. Two of you making it incorrect. So from this, inertia is the tendency of an object to resist a change in its temperature. Is that temperature? Hmm. Resist a change in its shape. Can you resist the change of its shape? The sign and motion. For those incorrect, do you want to try the answer again? Or just like when you answer, it giving you question. So from here, we think back the inertia is tendency of an object to remain at rest or to remain the motion. So part of this only relates to the motion actually. So for the first question, it's automatic, it's the motion, right? So for the second question, all the objects have inertia, whether they are moving or not. Correct or not? Actually, correct. It's true because when every all the object is that is moving without any external force or that is remain at rest, it's all considered there is an exist of inertia in it. So from the third question, the object with greater mass, I already speak out the answer. So the object with greater mass also have a greater inertia. On the fourth question, the friction and gravity are both example of force, correct or not? Actually, it's correct. Friction is a force to resist the change and to resist your motion. If our daily life without exist without any friction, you will always slide down when walking because you don't have friction. You walk one step and slide. So for the gravity, also it's a motion. It's a motion going down. You take everything up and release, it will move down. So it's considered as a force also. In the universal, there is no gravity. So you will see that everything is floating, including the water also. So for the fifth question, number 5. Because of the inertia, a resting object will remain off at rest, constant speed, school, remain at school, or remain at inertia. So actually, which is correct? A. Because of inertia, an object will remain at rest, remain at inertia. If you choose this question, what is the meaning of the whole sentence, right? It's very strange. That because of inertia, a resting object remain at inertia. Very very flat. So the correct is remain at rest. If because how about if I say that because of inertia, a moving object will remain at what? Anyone can give me the answer? If I change the question to because of inertia, a moving object will remain at a rest, remain at a constant speed, remain at school or home, or remain at inertia. Anyone of you can give me the example? If I say that I better write in the chat box. Chat box. If moving will remain at constant speed. Okay. How about others? Give me the give me your answer. Because of inertia, a moving object will remain at, or you can say ABC. A is rest, B is moving. Okay. Let's see. Most of you getting this incorrect, right? In the question 6. So I think most of you will choose the inertia. Moving, yes. So moving. Actually, so due to because of the inertia, a moving object will remain at constant speed. So 11 of you getting this incorrect. So for this, 15. Oh, here, right. Excuse me. So first, we look at the question. Because of the inertia, a moving object will keep at rest. No. Moving? Yes. In one spot? No. Inertia? This exactly no. Because it's asking you whether he already said that because of inertia. So you cannot say that because of inertia, a moving object will keep inertia. Inertia is not a it's not a word. It's a name. So we only having the answer A, B, C. So we're keeping moving. Actually, moving will keep moving. So the B is the only answer. Many of you getting this wrong. So I think that most of you still and not most of you, 15, 15 of you getting the concept wrong. So to change the motion, inertia must overcome. To change the motion, is overcome by a force. Why we say so? Because when the object stay at rest, it's have inertia, right? But if we want to change the motion, we will apply an external force. Maybe I kick a football. So the inertia must overcome by the force to adding on the object. So it will change the motion of the football from remain at rest into keep on moving. So to change motion, it must be overcome by a force. So is that okay for this? Ending now. Okay, so congratulations for those getting correct. So once you actually have a lot of video related to the tutorial, so I don't have to further explain. So remember to watch the video before doing the tutorial 2.4. Okay, all of you remember to do the tutorial 2.4. So any question about the inertia? Do you have any question? No? No question? Anything want to ask? No? So I will end it here. There have time left actually. You may watch the video for the bonus and then you can do the tutorial 2.4. From those you have question, you must stay in the Google Meet. I will cross it after 2:40 after 11:40 50. From those who have question, you can stay. From those don't have question, you may left now. That's all for today. Thank you for all of you joining the class today. Thank you.
Thank you.
So remember to watch the video and do the tutorial for today. Thank
Right.
you.
Thanks, Mr. Jim.
Thank you.
Thank you, sir.
Thank you. You're welcome.